At the beginning of the 20th century, when computers began to be produced, they were gigantic. Today, however, there has been the discovery of transistors that make them small enough to take them on our knees and fit them in our palms with phones or tablets. In addition, thanks to transistors, processors that offer much faster operation have been developed. A transistor is an electronic circuit element that regulates current or voltage flow and acts as a switch or amplifier for electronic signals. It was invented in 1947 and quickly replaced the vacuum tube as an electronic signal conditioner. It consists of a layer of doped semiconductor materials such as silicon and germanium, each of which can carry a current. The subject of this video is not the structure and history of transistors, but after a small introduction about transistors, we can move on to our main topic. You may know or have heard of transistors such as BJT, MOSFET, JFET, NPN, N-channel, and many more. But you may have trouble distinguishing them. If so, this lesson is for you. At the end of this video, we will basically learn that all 3-pin circuit elements are not transistors, how transistors are classified, and how we can distinguish them. Transistors are classified into two groups, BJT and FET. These expressions come from abbreviations formed from the initials of their English names. BJT comes from the acronym bipolar junction transistor, while FET comes from the abbreviation field effect transistor. The task of both transistors is to provide current control or voltage amplification as a switch. If we talk briefly about the differences between them, BJTs control current, while FETs control voltage and current. BJTs are quickly affected by temperature, while FETs are less affected by temperature. As such, BJTs degrade quickly, while FETs are more durable and long-lasting. Therefore, BJTs are generally preferred in low-circuit hobby electronic applications, while FETs are mostly preferred in low-voltage commercial applications. Also, BJTs have a low switching speed, while FETs have a high switching speed. BJT is divided into two groups as NPN and PNP. Symbols are as they are here. FETs are divided into two groups as JFET and MOSFET. While JFETs are produced in two types as N-channel and P-channel only as depletion mode, MOSFETs are of two types as depletion and enhancement mode. Each of these is produced in two types as N-channel and P-channel. This is the basic classification of transistors, friends. Here, you may have a question whether other 3-pin circuit elements, such as thyristor and triac, are not transistors. These are the other power electronic circuit elements that we see here are basically developed using BJTs and FETs. Now let's look at these other 3-pin power electronic circuit elements that we can mix with transistors. Thyristors are generally used for fast switching duty in DC power electronic circuits. Thyristors are similar to transistors. They also have 3 pins. Pin names are anode, cathode, and gate. These also occur in the form of PNPN. Triacs are similar to thyristors. The abbreviation triac comes from the initials of the English words triode for alternating current. It is actually formed by the reverse connection of two thyristors to each other. As such, they are used for switching purposes in AC power electronic circuits. Pin names differ from thyristor. These have 3 pins, and the pin names are as you can see here. IGBT, on the other hand, is a power electronic circuit element that is formed by developing the best features of MOSFET and BJT transistors. These are also 3 pins. IGBT comes from the abbreviation of the words insulated gate bipolar transistor. It is used in many areas for switching purposes. IGBTs, which can act as diodes when necessary or as triacs or transistors when necessary, are used extensively, especially in UPSs that require high switching speed. The other circuit element that is most confused with transistors is the voltage regulator. Voltage regulators are also 3-pin, but it is not a transistor. They ensure that the voltage is fixed at the output at values such as 5 volts, 9 volts, 12 volts. They do not act as amplification or switching like transistors. On our channel, there are videos about their basic working logic, friends. I will try to make new ones. You can view them later if you wish. As you can see, new circuit elements are emerging as a result of the rapid development of technology. As such, most of them are similar to each other, and we have difficulty in distinguishing them. So, how do we understand whether a 3-pin circuit element made of semiconductors that we see on an electronic board is a BJT, MOSFET, JFET, voltage regulator, or another circuit element? For this, we will write the numbers and letters written on it and add a datasheet expression to the end and search on Google. We will reach the information papers with the technical specifications presented to us by the companies that produce this circuit element. For example, when we look at the datasheet information of the widely used BC546, 547, 548 BJT transistor, we can reach the information that it is NPN and the pin naming. Here, we look at the surface with the name written while detecting the pins. We identify the pins according to the names corresponding to the numbers 1, 2, and 3. For example, in this BJT transistor, the left pin corresponds to collector, the middle pin to base, and the right pin to emitter. In addition, here we can reach a lot of information about the maximum operating parameters and electrical characteristics. Likewise, in the datasheet information of the widely used 2N5638 JFET transistor, we can access the information that it is N-channel, the pin name and location information, the maximum operating aperture degrees, and a lot of information about its electrical characteristics. When we look at the information of the IRF-Z44 transistor, which is also very widely used, we can see that it is an N-channel enhancement mode MOSFET. In addition, from its technical features, there is information that current can be controlled up to 49 amps and voltage can be controlled up to 55 volts with this MOSFET. Thus, we can reach information about the circuit elements that are stuck in our minds and whose properties we do not know by looking at the datasheet information in this way. In this way, you can choose the appropriate circuit element for the circuit you will make with a little research. Apart from these, there are many different circuit elements similar to the transistor. I have tried to show the most used ones here. I hope it was helpful and you liked it. Hope to see you in the next video. Goodbye!